Welcome students to the lecture number 10 of Computer System Architecture. Students, the main objective of this lecture is to understand sequential circuits. Students, in the previous lectures we have learned that we can divide the digital circuits into two categories. One is combinational circuit and another one is sequential circuits. Students, we have learned that the combinational circuits are those circuits in which the output depends upon the present values of the input. And the examples of the combinational circuits that we have discussed are the half adder, full adder. The other examples of the combinational circuits are encoder, decoder and multiplexers. Students, we have also learned that the flip-flops are the basic memory element of the computer, and flip-flops are used to store one bit of information in it. And we have various types of flip-flops such as SR, JK, D and T flip-flops. We have also learned that flip-flop is used with the system clock. System clock is a signal which is used to maintain synchronization among the various operations performed by the various circuits of the computer, right? Students, let's now understand what are sequential circuits. Students, sequential circuits are those circuits in which the next value of the output depends not only upon its present input values, but it also depends upon its present output. Right? Students, to achieve this application, we combine the combinational circuits and the memory element, that is flip-flop. So a sequential circuit is made with the combination of the combinational circuits and flip-flops. Okay. Students, the block diagram of sequential circuits is visible on your screen. You can see that it is a combination of combinational circuits and flip-flops. Students, you can also observe that the input of the combinational circuit is the input values and the output of the flip-flops. Students, you can also observe that the flip-flop is connected with the system clock, and also you can observe that the output of the combinational circuit is also going into the flip-flops. It means that the present output will be stored in the memory, and it will be used in deciding the next output of the circuit. Okay. Students, let's now compare the combinational circuits and the sequential circuits. Firstly, the combinational circuits are those circuits in which the output depend upon the input values only, and the sequential circuits, the output not only depend upon the present input values, but it also depend upon the previous output values. Students, the second difference is that there is no memory element in the combinational circuits, whereas there is a memory element in the sequential circuits. Now the examples of the combinational circuits are half adder, full adder, magnitude comparator, multiplexers, demultiplexers, encoders, decoders, whereas the examples of the sequential circuits are flip-flops, registers and counters. Students, an example of sequential circuit is visible on your screen. You can observe that it has two parts. One is the combinational circuits, which is made up of various logic gates, and one is the memory elements which contain the D flip-flop. Okay, so a sequential circuit has two parts. One is the combinational circuit and one is the memory element. Students, you can also observe that it is receiving the input X, and it is also using the value stored in the flip-flop as an input for the next state, and it is giving output as Y, and the equation for the output Y is AX bar plus BX bar, where A and B are the output values stored in the flip-flop, and the X is the input given to the circuit. Okay. So in sequential circuits, the output not only depends upon the present input values, but it also depends upon the values stored in the previous output values stored in the memory. Okay. Students, I think you have understood what are sequential circuits. Thank you for attending this lecture. See you in the next lecture.